Solutions to the Sec2 Mid-Year Exam 2014. In the first sum, we can simplify the expression by first reducing the fraction to the lowest term and fixing the terms with positive powers. The term which have a negative power in the numerator is moved to the denominator to convert to positive power. Similarly, the term with the negative power in the denominator is moved to the numerator. And applying the first law of indices, we have b to the power of 8 over 7a to the power of 8. In the second expression, we must note that the power of 0 belongs only to r. Therefore, 9r to the power of 0 is simply 9 times 1. r to the power of 0 is 1. Divided by, here we express 243 as 3 to the power of 5 and 32 as 2 to the power of 5. Next, we multiply the inner power by the outer power, 5 times 1/5 to give you 1. Similarly, in the denominator, 2 to the power of 5 times 1/5 is 1. And p to the power of 20 times 1/5 is p to the power of 4. And similarly, we have q to the power of 3. Next, we take care of the division sign by inverting the fraction. 2q cubed over 3p4. And cancelling the common factor, we have 6q cubed over p4. In question 2, we need to expand the expression. 2 times 2 is 4. X squared times x squared is x to the power of 4. The middle term is 2x squared y minus 2x squared y, which is 0. And then the last term is plus times minus y times y squared. In question 2b, a minus 7b to the square is simply a minus 7b times a minus 7b. This gives us a times a is a squared, minus 7ab is minus 14ab. Minus times minus plus, 7 times 7, 49. B times b, b squared. In the second part, we must remember that we must enclose the result in brackets. A times 2a is 2a squared. 6ab minus ab is 5ab. And 3b times minus b is minus 3b squared. Next, we open up the brackets and change the sign. We have minus 2a squared, minus times plus is minus 5ab, minus times minus plus 3b squared. Collecting like terms, a minus a squared is minus a squared. A squared minus 2a squared is minus a squared. Minus 14ab minus 5ab is minus 19ab. And finally, we have 49 plus 3 is 52b squared. In question 3, when we expand, again we must remember to enclose the result in brackets so that we can change sign. M times M is M squared. And the middle term is 0. AM minus AM is 0. Last term is A times minus A squared. Opening up the brackets, we have M squared minus M squared plus A squared. Minus times minus plus. M squared is removed, giving us A squared. Next, we have to make use of the first part to evaluate the numerical expression. We cannot use the calculator. So what we do is we could replace the numbers in place of M, letting M be 5, 2, 3, 4, 7, 2, 9. As you can see, this expression looks similar to this. So the square term simply tell us that M must be this value, and M plus A is this first number, M minus A is the second number. Thus, if M is the first value, then M plus A will mean that this number minus M will give us the value of A. Similarly, M minus A gives you the second number, and A can be found to be the same. Therefore, we can conclude that the numerical expression will give us the same result, A squared, which gives us 25. We can also solve the sum by using a second method. In this method here, we rewrite the numerical expression to take a similar form from what we see in the first sum. So M squared minus these two numbers is written as M plus A, M minus A, which in this case, if on careful examination, this number here is M minus 5, and this number here is M plus 5. And when we multiply out just like the first part, it gives us the result of A squared, which in this case A is 5, giving us 5 squared, which is 25. In question 4, we can rewrite the expression by expressing 125 as 5 cubed. And then again, applying the power into the brackets, we have 1 to the power of 2/3 over 5 to the power of 3 times 2/3, giving us 1 over 5 squared. 1 to the power of 2/3 is just 1, and 3 times 2/3 is 2, giving us 1 over 25. In the second sum, we have an unknown power, therefore we need to make a common base. 1 can be expressed as any base to the power of 0. In this case, we need the base 1/8 to the power of 0. When the bases are the same, the powers must be equal. Therefore, 2 minus 1 must be equals to 0. giving us x equals to half. In question 5, we have a simultaneous equation. The expression is not in an easy format, so we need to express it in the simpler form. From the equation 1, we multiply by 2 to give you a 4y and rearrange it such that 5x minus 4y equals to 3. And in the second equation, we multiply by 10 to remove the decimal point to give us 5x minus 2y equals to 27. Now we have a common term in 5x. We can remove it. We simply subtract the left-hand side. Equation 4 minus equation 3, which is 5 minus 2y minus 5x minus 4y. And on the right-hand side, we have 27 minus 3. 5x is removed. 5x minus 5x is 0. Minus y minus minus plus 4y. Minus 2y plus 4y is 2y. Thus, we have y equals to 12. We substitute y equals to 12 into any of the equation. In this case, I chose 1. So 5x minus 3 over 2 is equals to 2 times 12, giving us 5 minus 3 equals to 48, and 5x is 51, x is 10 and 1/5. In question 6, we have the mass of a hydrogen given and mass of an oxygen atom. Thus, to calculate the mass of a water molecule, which is 2 hydrogen and 1 oxygen, we have two times the mass of hydrogen, 2 atoms of hydrogen, and 1 atom of oxygen. We first multiply the 2 with 1.67 to give you 3.34. We don't multiply 2 into the power of 10. Next, to add the 2 standard form, we need to make a common power of 10. That is 10 to the power of minus 23. So we split the 10 to the power minus 24 into 10 to the power minus 1 and 10 to the power of minus 23. 3.34 times 10 to the power minus 1 will be 0.334. So once the power of 10 is the same, we can factorize it out and add the numbers, giving us the answer 2.994 times 10 to the power of minus 23. In the second part, we need to find the number of molecules. To find the number of molecules in 250 grams of water, what we simply do is to take 250, the weight of the water, divided by 1 molecule of water. Okay, divided by the weight of 1 molecule of water. This will give us the total number of molecules. To divide, we simply split the numbers such that we have 250 divided by 2.994, and the powers of 10 is separated into 1 over 10 to the power of minus 23. Note that the power of 10 is in the denominator. So dividing this, we have 83.500334, and the power of 10, which is negative, is moved to the numerator to convert to positive power. And reducing this to 3 significant figure, we have 8.35 times 10 to the power of negative 23. In number 7, we need to factorize a difference of 2 squares, and we know that a difference of 2 squares will give us one side negative and the other side positive. So here is 5 times 5 and x plus 3y times x plus 3y. Okay, 5 times 5, 25. X plus 3y times x plus 3y is x plus 3y squared. Okay, to get a minus, we have minus times plus. To get a 4 is 2 times 2. And to get a square here, we have 2x plus y times 2x plus y. This comes from the formula a square minus b square is a minus b, a plus b. Now we simplify it. We have 5x plus 15y minus 4x minus 2y. On this side, 5x plus 15y plus 4x plus 2y. And simplifying it further, we have x plus 13y, and on this side we have 9x plus 70y. In question 7a part 2, we have 4 terms, which means that this is a factorization by grouping. In the first group, common factor is 7m. And in the second group, common factor is minus 3a. Note that the terms in brackets must be the same so that we can factorize it. In 7b, we have to simplify an algebraic fraction. To simplify, we need first to factorize it. And we factorize the denominator as well. We note that if the numerator has a x minus 3, then the denominator should also have a common factor which we can cancel away. Therefore, we already know one of the factor. The other factor is therefore 3x times x 3x squared, and this must be 5, a positive 5. Because positive 5 times minus 3 will give you minus 15. Now we cancel the common factor to give us the result 4 divided by 3x plus 5. In the next example, we note that x minus y is 20, xy equals to minus 36, and we need to find x squared plus y squared. By examining the terms, we can tell that this is just simply the formula x minus y squared, which gives us x squared minus 2xy plus y squared. So what we do next is to substitute the values given to us, which is 20 squared, and rearranging it, substituting xy, which is negative 36. Thus, solving this, we have x squared plus y squared is 328. In question 8, we need to express the 3 fractions into a single fraction. To do that, we first factorize the denominator. Next, we want to make a common denominator. In order to make a common denominator, we must have an x minus 1 here, so that it will be the same. And to do that, we simply change the sign here to plus and reverse the positions. Now we have the terms are all in order, and we need to make a common denominator in order to add the fractions. We do not have a x plus 1 here, so we multiply by x plus 1 over x plus 1 to get x plus 1 in the denominator. Now these two fractions have the same denominator. And on this side, we are short of a x minus 1, so we multiply by x minus 1 over x minus 1. Now all the fractions have the same denominator, which is x minus 1 times x minus x plus 1. And we put all the numerators over the same denominator. And simplifying this, we have 5x minus 5 minus 3 plus x plus 1. Notice that we do not expand out the denominator. We keep it in the factorized form. The result is 5x plus x, 6x, minus 8 plus 1 is minus 7. In question 9, we have a direct proportion. We are given that V is directly proportional to the cube of its radius. The word directly tells us that V must be equals to the constant times the cube of its radius, which is r cube. Note that k is a constant. Next, we need to find k by substituting the given values. When v is 162, r is 3, so 162 equals to k times 3 cube. 3 cube is 27. And this gives us k equals to 6. Therefore, the equation is v equals to the known value of k times r cubed. Now we can use the formula that we have found and substitute in the value of the volume. 384 equals to 6r cubed. And solving this, we have r is equals to 4. Thus, the radius of the solid is 4 cm, or 4 units. In question 10, we are given a solution of the equation. Now, since x equals to 7 is the solution, therefore, it should satisfy the equation, which means that we can substitute it into the equation. We get x is 7, so 7 square minus 7 times k equals to 28. And that gives us 7k equals to 28 minus 49. And that gives us k is minus 7k is this, and k equals to 3. Since we have found the value of k, we can now put the value of k into the equation to get x squared minus 3x equals to 28. This is a quadratic equation. Thus, we make the right hand side 0. And then we factorize it. We already have the solution x equals to 7, meaning that x minus 7 must be one of the factor. Because when x is x minus 1, x minus 7 equals to 0, x equals to 7. Thus, the other factor must be x plus 4. Thus giving us the two solutions are x equals to minus 4 or x equals to 7. Therefore, x equals to minus 4 must be the other solution. In question 11, we have Veronica deposit 30,000 into a bank. She need to choose either CMT Bank or HSB Bank. CMT Bank uses compound interest at 3.45% per year, compounded half yearly. Therefore, the interest in CMT Bank is, using the formula for compound interest, amount is principal times 1 plus R to the power of n. The rate is given per year, but we are interested in half yearly. Therefore, the rate must be divided by 2 to get the rate per half year. And it is for 2 years, and there are 4 halves in 2 years. Therefore, n equals to 4. Using the calculator, we arrive at this answer. But what we are interested in is the interest. Therefore, we need to subtract the principal, which is 30,000, to get the interest. The HSC Bank uses a simpler formula, which is a PRT over 100. P is the principal, and the percentage is 3.5 over 100 for 2 years, which gives us 2100. Comparing the two, we find that CMT gives us more value for the interest. Thus, the reason on which bank she chose is that she will choose CMT Bank because she will receive $24.18 more in interest. In question 12, we have another sum on proportion, this time inverse proportion. The force is inversely proportional to the square of the distance. This is interpreted as F equals to K over the square of the distance, which is D squared. K is a constant. And similarly, we need to find the value of K when the force is 2 newtons. The distance is D. D simply represents a number. So it still works in the same way. F is 2, K over the value is D, and square it. Therefore, K is 2D squared. The equation is F equals K, which is 2D squared, over the unknown value of D squared. The second part requires us to find the force when the distance is double. So now the distance D is doubled. So D becomes 2D is doubled. Substituting into the equation, we have F is 2D squared over D, which is 2D squared. Okay, simplifying it, we have F is 0.5 newtons. In question 13, we are given a rectangle, and the rectangle is folded. Note that we have a right angle here. First, we need to find the area of the rectangle, which is just length times breadth, or 2x minus 1 times 4x minus 7 cm squared. Then the area of the triangle APR is just simply half of half base. Now what is the base? Now these two triangles are the same, so PR is just 2 cm. So half base times the height. Okay, the height here, AP, is just simply AD. So it is 4x minus 7. This length is the same, 4x minus 7. Okay, simplifying it, we have 4x minus 7 cm squared. We were told that the area, the shaded area here, is 381 cm squared. To get this area, is just the whole rectangle minus the two triangles. The area of the rectangle is 2x minus 1 times 4x minus 7, and this area of rectangle minus two triangles. One triangle is 4x minus 7, so two triangles is 2 times 4x minus 7, and this gives us the shaded area. Rectangle minus the two triangles to give the shaded area 381. Expanding this, minus 4 minus 14 minus 18x plus 7 minus 8x plus 14 equals to 381. Okay, simplifying it, we have 8x squared minus 26x. This is 21 minus 381 equals to 0. Okay, we simplify it further. We will have 8x squared minus 26x minus 360 equals to 0. Dividing by 2, we will have 4x squared minus 13x minus 180 equals 0, as shown. Next, we need to solve the equation. To solve the equation, we use the formula x equals minus b plus minus b squared minus 4ac, root of b squared minus 4ac over 2a. Here a is 4 from the formula. A is 4, b is minus 13, and c is minus 180. Put it into the equation, and Use your calculator, we get the values 8.527, and x is also minus 5.277. Next, we need to find the area of the triangle. We know that the area of the triangle is 4x minus 7. Area of triangle APR is 4x minus 7. We chose the positive value because the length cannot be negative. And we rounded our answer to 27.11 as required to 2 decimal places. This concludes the discussion of the mid-year 2014. Thank you.